Welcome back. So on today's agenda, we're going to do 9.2 notes the first half on special right triangles. We have some practice embedded in the video. And then for homework tonight is a Google form. By the end of class today, you should be able to identify and solve for missing information in special right triangles. So the first one we're going to look at right now is the 45, 45, 90-degree triangle. So this triangle is formed by connecting the two diagonal vertices of a square. So like notice in this photo here, we have square ABDC. I connected A to D and it creates a 45, 45, 90. Because remember, a characteristic of a square is when we make the diagonal, it cuts that angle in half. And if we go ahead and take out this triangle, and the square side lengths are all the same, so in my example, I'm saying each side is 5 centimeters. And if these two sides are 5 centimeters and I want to find the length of AD, what is it going to be? So you should have gotten, once you applied the Pythagorean theorem, a squared plus b squared equals c squared. Remember, these are my legs. The right angle points to the hypotenuse, so I'm solving for c. And I get 50 is equal to c squared. I need to isolate c, so I'm going to take the square root of both sides, and I get the square root of 50. But remember, I asked you to write it in simplest radical form. So that means what I need to do is rewrite this as factors, and I can factor this out to be 25 and 2. The square root of 25 is 5, and the square root of 2 is just 2. So that means the length of AD is 5 square root 2. In a 45, 45, 90 triangle, both legs are always congruent, and the length of the hypotenuse is square root 2 times the length of the leg. So based off the last example that I showed, plus the example embedded in the video, you should have seen this pattern of always just taking the leg length and multiplying it by the square root of 2 to get the hypotenuse. So here's another example. We want to find the value of x. So if I know this leg is 7, then I know that the other leg is also 7, and that these two angles here have to be 45, given that we're given that these two angles are equal to each other. So if I have a 45, 45, 90, and I know my legs are 7, that means that my hypotenuse has to be 7 square root 2. I can double check that with the Pythagorean theorem, and it checks out. Now I want to find the value of x, and this time though, I'm given the hypotenuse. So it's a little bit different of a process. So again, I'm going to apply the Pythagorean theorem. I know my leg values are both x, so I'm replacing a and b with x and squaring them, and it's equal to 3 squared, which is 9. I'm going to go ahead and divide both sides of my equation by 2, and now I get x squared is equal to 9 over 2. My last step is I want to square root both sides, and it gives me the square root of 9 over the square root of 2. Square root of 9 is just 3 over the square root of 2, but remember, we cannot have radicals in our denominator. We've talked about this before. So to get rid of that radical, we're going to go ahead and multiply by the square root of 2 to both our numerator and our denominator, and we're going to get 3 square root 2 over the square root of 4, and we simplify the square root of 4 down to 2. In this example, we want to go ahead and find the value of x, so go ahead and try. So what you should have done looking at it is that you know that A, B, and BC are going to be the same length. So A and B are both 10 square root 2. We square both of those values to equal the c squared, which is our hypotenuse. And I'm just going to show you guys, remember 10 square root 2 squared. That's like saying 10 square root 2 times 10 square root 2. So I just went and expanded that out. And then 10 times 10 is 100. Square root of 2 times the square root of 2 is the square root of 4. Remember, the square root of 4 is just 2. So 100 times 2 is going to give us 200. 200 plus 200 is equal to c squared. So 400 is equal to c squared. The square root of 400 is 20. So our final example is 6 foot tall student is standing 60 feet from a tree and is looking up at 45 degrees. What is the height of the tree? Well, this person standing here is 6 feet tall. They're looking up at the top of the tree and it's a 45-degree angle. That means my other angle has to be 45 degrees, because if we're talking about the ground and the tree, that's a horizontal vertical line which produces a perpendicular angle, which is 90 degrees. And I want to know the length of the entire tree. If I know I'm standing 60 feet away, that means based off of this triangle, my height from the bottom of the triangle to the top has to be 60 feet. But remember, I want to know the height of the tree. I still need to also think about the fact that the tree doesn't just go from here to here, it touches the ground. So if I know from here to here is 60 feet, I have to also think about the fact that from here to the ground is 6 feet. So I'm going to go ahead and add 60 plus 6, and it gives